Welcome back to the second part of the West Michigan Lakes for SolidWorks Users Group machine design presentation. If you didn't watch the first version or the first presentation, it's been recorded and I'm sure there'll be a link somewhere on whatever screen you're looking at on the internet. These files should be made available as well. So back to here, let's finish out this, and then Jerry said the other part is really fun. That does look fun. All right. Okay then, we'll finish out this side a minute and talk more about the manufacturing aspect. I need to relieve this a little bit because we can't hit that tube, and I'm sure we have to do something similar like this to here. Yep, same similar thing. So let's just relieve that back. I'm just gonna edit my sketch, and let's say from here we'll just move back and then trim that away. Something like this, sure, whatever. And then maybe make this bigger because we lost some footprint. See how that looks. Still not the best. So let's make that 2.5. This is again another instance where I use Instant 3D, which is pretty rare. But I could kind of drag this around, right, until I can generally match the curve or until it looks kind of good. Whatever, and then I'll type in a real nominal dimension. All right, so again, I'm going to check for manufacturability again. This now become very difficult to manufacture. So that wasn't necessarily a good change. But I did kind of figure out what my envelope was. So here I'm just going to draw a line straight up, draw a line over. Instead of doing a nice, sexy chamfer angle thingy, we'll just make it square and ugly, and that will kind of work. I don't really like that sharp point because they could hit the tube against it, and it just looks dumb. So maybe we'll just edit it one more time and take that out. Maybe we'll just bring those to a point and make that coincident to the origin. And make our base here 3.5. Now I can practically make that. I could actually, I'm going to edit it one more time. Number of edits doesn't matter, right? It's not a bad thing to keep editing it and refine it. I'm just going to make that collinear to there, so it looks nice and it looks like that. And then it looks nice and we got lots of room. No problem. All right, so now I'm going to just open this up. In this context, dowels are what holds your alignment. So I'm going to put in 2 dowels and 1 bolt hole, because as long as the bolt holds it in place, nobody cares. I'm assuming that's acceptable. So here under ANSI inch, we'll do dowel holes, 1/4 inch, press. Anybody want to tell me why I would press them into this plate instead of press them into that block? So you can press them out. What's the rule of dowels? Never press into a blind hole. Whoever said that, you get kudos. I don't know who said that, because that's right. Ooh, I have candy. It's in my bag. So I'm a big fan of not using dimensions. I don't know if I've mentioned that already. So in this particular instance, because I want everything centered and stuff, because it looks nice, because it's all about the looks. In this instance, I can put my holes evenly spaced from the edge, centered off that tab with 0 dimensions. I'll bring this up again, right? So this line is going to get me the center of this tab. This is perpendicular to that edge, which gives me a distance. So I can draw 2 lines, perpendicular and parallel as needed, make them equal. Now I have a 0 dimension, very robust design intent hole pattern that's going to fit nicely on that block. So same thing here, I can just edit that block, use my external references, and say dowel holes. This I'm going to switch from press to slip, clearance as SolidWorks calls it, especially since it's a longer hole and going all the way through. It's convenient to have that slip. Now another option is you could have that go all the way through and you could press that and then the ends could be slipped, but then I don't really want to press and drive a dowel 1.5 inches through. So if I put dowels on my design, I would probably put in inch dowels on both sides. If I don't put dowels on my design, then the guys on the floor can do whatever they feel like doing. Once that's done, I'll just edit this and put in, again, if it has to be counterbore, I have to mirror. If it doesn't have to be counterbore, I can do it normally. I don't know, what is your standard, Jerry?
It really isn't in this particular case.
Yep. Cool. So we're going to save the effort, save the cost of making a mirrored part, because the more consistent you can, higher volume singular parts you make, the more money you save. So 1/4 inch for a 1/4 20. And because dowels are the most important, and I would much rather have a misaligned bolt hole than a misaligned dowel hole, I always put my dowels in first, because that's my record of truth. And then I put in my tapped holes or clearance holes or whatever after my dowel holes. And then that way, if my dowel holes move, my tapped holes go along with it, and through holes. So we'll do this as blind. Yeah, sounds good. Unless there's compelling reason to otherwise, you always accept the SOLIDWORKS defaults for a blind hole. I do want to check this to make sure I'm not really getting in the way at all. This barely penetrated, so the bolt's going to stay back here, pressing a dowel, no problem. That's clearance, no big deal. I'm fine with that. So let's look at my planes. I have no planes logically in the middle, so I'm going to throw a plane in there, run my mirror command. Instead of bodies to mirror in this instance, I just want features to mirror. So we'll grab that hole, mirror it about. Now I've got a hole on both sides. And now if I did everything right, I should have mounting plates on both sides, doweled. I don't feel like putting the dowels in the holes in the bottom because, again, if you came to this presentation to figure that part out, you're probably in the wrong presentation. So we'll assume that's properly doweled and bolted to the bottom. What last thing should I do to actually have this part be manufacturable? Particularly the inside sharp corner. Adding fillets to inside corners saves money. Adding fillets to outside corners sometimes costs money, but generally unnecessary, right? If this isn't a CNC, it wouldn't matter anyway. Anyway, so I don't know if we'll get to the 2D detail prints today because it looks like we still got more fun design work to do, and I'll have to figure out the errors in my tree, which is really weird because if I suppress these, they go away. I thought. Well, they just move around. That's helpful. SOLIDWORKS. Okay. So anyway, I don't like the errors, and I'm not going to take the time now to figure them out. So we've got that, no problem. So I do the same thing here as I did on this part, figure out where my axis of revolution, or where my rotational will be, to only have a single angle, not a double compound angle. And then I would do the same type of thing here with a plane and a 3D sketch and orientate my part, make the cut, all while keeping manufacturability in mind. Jumping over here, what are we doing here? I don't know. I can look back at your picture. So it's
basically that nest there.
Oh, those are.
They have to control where the bend and the end of.
Those are the files you gave me. Data for Andrew. Look at that. Feels so special. As you can see, I've not prepared. He gave me this flash drive earlier today. So let's figure out what it is. Figure out what we have to do. I probably should have put that folder in there. Supplied parts. What am I
looking for the actual?
Yeah, whatever those plunger things are.
Oh no, I was talking about the red part. See how the tube's nested inside?
Oh,
that?
yep.
It captures the bends and the elbows.
Okay.
Dimensions of,
okay.
Because the orientation of that was critical in this particular.
Okay, no problem. We'll start on the nest first. Okay, so how'd that picture work? Okay, so it's on a riser, so no problem. In this particular instance, because I don't necessarily have the part oriented to, or the nest fixture part oriented to this, I'm just going to create a blank part and just throw a block on it. Because again, all good designers start with your origin center base sketch. And I'm totally guessing on dimensions again. We'll say that's an inch, 2 inches. Save this. This is nest 4. Drop that into the assembly. So because it was on a riser, it looks like my part is positioned slightly different. So we'll just mate it to the bottom, no problem. So we'll find the bottom of this, select other, hold down control, pick coincident. So is it basically like that then, cut on an angle? Or I could angle it, right? Is it basically in this, that would fit like that? Okay. I want to, we'll just mate these in place and then I'll cut the part on an angle. Breadcrumbs are your friend. The standard keyboard shortcut in SOLIDWORKS is D for breadcrumbs. Let's flip that, okay. That looks good. Let's say that's 4 inches, maybe 5. All right, now we just gotta position it this way. So I'm going to go from my right plane to the right plane in the assembly. So my base plate is still probably subject to change. And this is 37.625 nominal. Man, SOLIDWORKS is just giving me warnings all over the place. It's not happy about something. Okay, so we don't have to touch this fixture at all, the clamp itself.
You'll have to, yeah, you'd have to locate that.
The bottom. So this part does need to be bigger. Okay, so we're capturing the bends in the tubing and this part here. Okay, so same thing, I'm going to open this part up and start tab key to get rid of the extra bodies that I don't want. That looks good. Okay, save, yep. I could delete them out of the feature tree, but hiding them is helpful, especially if I want to see the open position and make sure I don't interfere or something. All right, that's going to be hard to machine. Do I have to capture these sidewalls?
Not necessarily, no.
No.
Just the bottom of it, and again, that hole right there.
So I have to align the hole, support the bottom of this flange so I can drive the screw in.
Right.
And I can contour that angle, but setting it up to put that hole in is going to be hard. Quite hard.
I think we made 2 different pieces, not one block. We made one block to hold the tubes, and then another block just to hold the bracket.
Yep, so I would agree with that. So this is at an angle, so I could have one part rotated. So what's this gonna be? Is this perpendicular? No. Okay. So in this instance, right, I'm gonna edit the customer part again, start a 3D sketch. 3D sketches are amazing alignment tools. I'm gonna just draw a random sketch here, say that this point is on that face, and then that point is gonna be concentric to that hole, and that line there is concentric. So now we know that it's going straight up and down in that line, that line is going straight concentric to that hole, and we can say that that point is gonna be on face, and then draw a line randomly and another line randomly. By the way, when you're drawing lines, SOLIDWORKS likes to chain lines together. If you double click in space, it'll unchain. So you can draw a line, double click, and draw another line, double click, and not have to get in and out of your line command. So let's make those perpendicular. Let's make that perpendicular and those two perpendicular. And then let's make that parallel to face. Okay, so that's the orientation which I need the block to only have the single angle for setup. No problem. Start a new part. Save this. This is nest 5. Go back. Insert that nest 5 component. And top plane again is going to be coincident to the top plane of my plate. The front plane is going to be coincident to that line. The right plane is going to be coincident to that line. Now the origin for my part should be right at that bottom point where it's intersecting that. So then let's edit that part on the top plane. Let's start a rectangle sketch. Again, I can't use my my orthographic views, right? I can't use vertical or horizontal because a vertical line looks like that. Oh, I can. Oh, that's right, because I rotated the part. Duh. All right, so I can, right? No problem. So there's my block. Getting confused as to what I'm working on. And I might be able to even work off the origin because the origin's right there. So let's say that we're midpoint to the origin, normal to. That's all I really have to capture, right?
Yep.
So I can't really work off the origin then. So let's do, I can at least midpoint it this way. So grab the origin, grab that line midpoint. I can bring this back like that. I really got to do that. Okay, so let's say this is 1.5 inches. Let's say that is 2. And let's move that back a little bit, and let's dimension this line here to 1.75. Okay. So then we're gonna just extrude a little bit just to get an idea. So I want to offset this surface 0, offset that surface 0. Do I want to engage this at all, or just be far enough away from it? Doesn't matter.
You don't have to engage it.
Okay. So if I don't have to engage it, next pro tip: if you have a flat congruent surface that you want to extrude up to, you can double click on it, and it will. What's the term? It'll terminate that it'll elongate that surface to full termination of your extrude. So I don't have to do any surface offset, anything. I want 1-to-1, so size for size in this context, and I can just green check and OK. Now I do have to relieve that, and I do have to have another one here. So in this instance, I don't necessarily want to start a sketch here and go up because it'd be up on an angle. So I'm just going to go on the top plane again, start a sketch, do normal 2. Find my rectangle here and say that's about what I want, except this line we want on an angle like that, and I want it to be clear from that. Nope. Before you dimension, you should always make parallel. Now that it's parallel, dimension that to that line there. Let's say I want to stay in 1/16 away. Fine. And now kind of crowd that. Again, this square, because it's not squared apart, doesn't really matter to me. And then I can extrude, double click, green check, like that. Do I have to undercut this and support over there more?
Just so you have enough for the screw, so it doesn't bend the tab when you drive the screw in.
Does supporting the tab back here, is that necessary?
We did.
Okay.
Yeah.
So you just have to have an undercut then. Okay. So then, I'm just going to edit this and flip that dimension. And again, because I'm terminating up to a flat surface, it'll follow that through for me. So I really want, I probably want that to be size for size. So let's come in a little bit and let's dimension to that edge, because I don't really want to machine that radius. So let's just stay at 32nd away from that radius. And now I've got my support up there. I do, however, have to machine that undercut. Which, what would you, just what?
Put a radius in there.
Well, I'm interfering, so radius would, I'm just thinking, so looking at it like this, right, my mill is straight down, but I need that undercut. So you have to use like an angle cutter, we'll figure that out, right? Stuff like that I just don't know, I have to think about it, we'll move on. So I can edit this part again, or edit this part, add a hole. Now I don't have to accurately align on that tab on that. Right, so we're gonna just add a hole here and do a plane hole, fractional, 1/4 inch, blind is fine. And I should be able to grab the edge of that. I mean, more accurately, right? I can right click there and select other and drill down inside of here. Maybe I'll grab the bottom of that and make it concentric. That hole doesn't look big enough, but I'll just say go ahead. Tab again will hide the part in my graphics view, so I can just measure this, 236. So shift tab will show the wrong part. There we go. So 236, open my part here. This is 25 because it's fractional. So let's move it up to, and the show decimal equivalent here shows the decimal equivalent in the combo box, which is quite handy. So let's go to 516. Let's make this transparent, kind of see what I'm looking at. Big enough to clear past that radius. A little bit thin there. That radius itself is 251. Okay, so maybe it's a little big. Let's go up to 9/16. All right, sure, good enough, right? I'm holding it, I gotta do a relief there. So who knows how to select a transparent component with a background component? Hold down Shift, exactly, and you can make it untransparent. So let's edit this component again. Now are these two surfaces parallel? They are parallel, so that's good. At least the saving grace with this part is you have flat surfaces and they tend to be orthographic parallel and 90. So once you get your fixture figured out, you can at least kind of blow through it that way. I'm probably gonna have to drill up through there. So let's actually edit this, move it over a little bit. And if we edit this, put a point there, make that body go away. Same type of deal. I'm going to draw a line, and say from that point to there, and from the point to the corner, point to the corner, and there, and then make that midpoint. Okay, so there's my clearance hole. Use the same hole feature, no problem. Seems to work just fine. Might have to be a little bigger or moved over, but you get the idea. So this should be relatively simple. I can just put my bolts and dowels on the bottom and bolt it right to the plate. The complexity of making this particular detail are those holes. But because it's a single angle, I can still clamp this in the vise and position like so. The challenge is picking up the placement of that hole in relation to anything else. So what I'm gonna have to do is draw on here. This is like the poor man's way of doing it. If you can, if your mill will contour and hold it accurately, this works really well. I'm gonna just draw a sketch on that face and offset over. Say 1/2 inch through all, cut that, and that would obviously be cleaned up. But the idea is, let's just make that collinear, delete that horizontal. The idea is in the mill like this. Nope, that didn't help at all. Got my angles messed up. Let's draw it this way. Yeah, so let's turn on our temporary axes and draw something that looks like that. That's vertical. This parallel to the temporary axes. That's coincident. That's collinear. Cut extrude through all. All right, so the idea is if this is set up in the middle, I can contour this with a ball nose, get it pretty flat. And when I come up like this, I can indicate, and because I'm contouring this whole surface, right? I can indicate this entire surface flat, so now I know I'm perpendicular to that surface. I can use this edge as an edge finder to pick up, and then this edge, which is square anyway, to pick up. So that's how we're able to accomplish that. Now that I'm set up like this is how I just figured out I'm going to take care of my undercut, because I can cut straight down through there. So I'm just going to start a sketch on here, invert that, cut down to there, and so this is how I'm going to set it up in the middle like that. Indicate that off, indicate this, edge find off here, edge find off here. Can accurately put in my two holes, trim that side, and everything should be magical. Let's see. Got my clearance, got my holes. Yes, my sketch isn't fully defined. I probably wouldn't even at this point yet because I'm still moving things around, right? This is a manufacturable detail actually. Minus the necessary fillets around here. I don't really want that filleted. So let's say this is an 1/8 inch. Before I do that, let's fillet these edges a small amount. Then let's fillet this. So now I can machine all that, dowel it. Oh, I still have this hole. So this is 3/5. Is that a 5/16? Or some metric equivalent? This is 3/5/4.
Yeah, I think it was metric.
Tommy, how dare you know that off the top of your head? All right, so we'll do metric, dowel holes, 8 mil, press fit, through wall, find my center, drop it there, like so. So that's no problem. That was the easy one. Any questions so far? Everybody agree with me that communists use metric? Is that a thing? Yes? Okay. Just checking. Didn't know if it was just me. It often is, so you never know. All right. Now we don't have to hold the rest of that bracket you said, just the tubing.
Right.
Okay. So if this, we can bring that down to maybe 5. We could trim that off, right? That interference is okay. How much of this tubing do I have to grab?
Right, just behind the elbow.
Okay, so if I bring this down to like 4.5, and I trim that off, that's okay? All right, something like that. Okay, so it looks like I need some more height. And so now that this face is where I want, this block is currently mated to here. So I'm gonna breadcrumb, find that mate, delete it, and I'm gonna backwards mate it here to that side, distance, and okay. So now I've changed my point of anchor, so if I change this to 4, the block's gonna shrink in instead of the other direction. Okay, so.
I recommend you make that to the center plane rather than the edge plate. Change the size of your plate, now you screw up your location.
Yeah, sure. I don't necessarily disagree. So when you said center plane, I thought you meant center plane of the block. So let's do the front plane of my assembly. Grab that. All right, thanks, Radar. So how high do we have to capture this? If we go up to, like, say 4 inches, let's look at your picture again.
Pretty much the whole thing.
Pretty much the whole thing, all right. So 4.5. Okay, so there's that. So I'm gonna edit the part. I'm hiding the body. Hiding the body. And now we're gonna start offsetting surfaces. It's not super important that I'm 0 to the bottom, right? I can do 10th all the way around. Okay, so under surfaces, let's do offset 0.01. Now you have to go around these as well, right? Okay. Okay, so let's hide the body again. All right. So we've almost got full, almost goes all the way through. So I should be able to do an extend on this. Now I should be able to do a cut with surf. Do I want to do that? I don't want to do that. What I think I want to do, now this has to drop straight down, correct?
Right.
So on the top plane, can I do this? Can I do curves, split line, projection, silhouette? All right, it's been a while. I'm gonna struggle through this command. If you all know what I'm doing wrong, tell me. Does this work? It worked. That was easy. All right, so we repick all of our faces. In this instance, I can right click and do select tangency. I couldn't before because it would have gone all the way down the pipe, but now that I've extracted out my surfaces, I can just tangent, save me the clicking. or it could air out. I think I can't do both at the same time. So we'll have to do that again. Top, curves, split line, select tangency, go. All right, now I can do a, what am I trying to do? I forget. No, I was trying to do a cut strategy that's not working. I know what I'm trying to do. Not that. I still might need them, so I'm just going to suppress them for now. Never mind any of that. Get all of that. Okay, so that still looks good. All right. So I'm going to do a cut with surface, grab the body, cuts. Cut with surface, grab the body, cuts. Delete these bodies. And then now is where I want to do the split lines. Maybe. Should be able to do this. Ah, yes, okay. I'm remembering now. Okay, before I delete the bodies, I'm going to start a sketch in the top plane, hide my block. Now I should be able to pick these edges. Well, that's going to be a nasty edge. We're just going to go straight through, no problem. Pick these edges, convert them. Oh, it couldn't convert. Convert, convert, can't convert that. Convert, 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 convert. Okay, we're going to convert that all the way out, that all the way out. Why won't that convert? Seems like that would convert. All right, anyway. Convert those. I should convert. Yeah, there we go. Really not sure what strategy is going to work for this.
Can you go to the top view and then change it to a hash?
Go to a top view and change what?
And then change your view to hash lines.
Like this?
And then you can select if you use it.
It's just not, the entities aren't converting, that's the problem. All right, new strategy. That's not working out well. Let's try splitting that like normal. It's these bumps. Do we need to align and keep those bumps, or is it just the elbows?
Just the elbows in the direction of the tube. Actually, there's clearance in there for those bumps.
Okay, so we're gonna ignore the bumps.
Yeah.
Nobody cares. Sweet. Okay. This is fun. I'm thinking. All right. So let's edit this feature. Let's not convert the bumps or that, because I can extend that surface out to touch. Oh, no, that was a split line feature. Let's try the offset feature. So I don't need the bumps if they're truly clearanced away. I don't need that because I can extend that surface. Okay. We're not contacting the ends either, right?
Right.
Okay, so it's just that. No problem. I can deal with that. Okay. So now, yep, and all that's gonna blow up. Got it. So let's extend these two. Oh, same body only, okay. Let's extend that, extend this. So we'll just manually sketch out or clear around those bumps, but at least we're clear through there. Then, this might work. It's at least a confidence booster for everybody else. You're like, ha, he's struggling too. Oh, that's right. Different bodies. Top, split. Okay, so what I'm thinking I'm trying to do, we'll see how this works. We'll delete those. Delete. Click the right button, Andrew. Delete, delete, delete. Okay, so now I've just got the bottom halves that I care about. And now I wonder if we can do something funky like boundary surface, right click selection manager, grab all of that to selection manager this. Ho ho ho. Is that allowed, Jerry?
Sure.
Okay. Thanks. And then let's do a ruled surface off of here. Let's make that perpendicular to vector. Pick the vector as the top plane. Say that's like 2 inches. Ooh, that's a nasty curve. That will have to be cleaned up. This one should work well. All right, let's show the body again. Getting somewhere. We don't actually need those 2 surface cuts. Cut the surface. Okay. So it looks like if this is slightly bigger. And that is slightly extended. So let's extend that. So if you just roll back, right, because SolidWorks is parametric modeler, you can just roll back at your geometry and something will go horribly wrong and then you got to go fix it. What happened? Okay. Your boundary. Oh, because I have my delete command. So don't roll past your delete body command if you're still trying to use your body. Rule number 1. Okay. Still needs slightly more. 3.
Just making sure that surface.
Yeah. Except that intersection there is really not being happy. So let's edit this. Let's only do that side because that looks good. I'm okay with that. And then I can, in 3D space, draw a line from there out. So let's make that line parallel with that, which we can do in 3D sketches because 3D sketches are awesome. Then I should be able to do a boundary surface from there to there with the direction 2 selection manager pick of that, and then go. I think that was probably more work than it needed to be. I think I can probably, can I do a sweep? Can I sweep? Or I need a sketch profile. I don't know, I'm just trying a different way because I'm curious. I think I can sweep that sketch along that edge. Nope. All right, looks like the way I did it first was probably the best way. Delete all that, delete that, go back to that, turn back on my body. Let's extend all this out a little bit more. So as long as the surface isn't contorting as you're extending, you can extend infinitely, it doesn't really matter. Now I can't cut with surface yet because this is not all knitted together. So let's just do a giant surface knit, make all this happy. Now oops, I missed a knit. Now there is a theory that says you should fillet your surface before your body. I don't know that it really matters one way or the other. I think there's many other, I think it's more of a what are you trying to do than a best practice discussion. I always like filleting my body instead of my surface because body fillets tend to be a little bit more lightweight and reliable. And then that way I can surface more things on my body like the corners of my block and stuff instead of just being constrained to my surface. The same fillet command works either way. All right, so that's okay. That's a little much, right? So maybe we just cut that off. So I could start here. Again, make sure you edit your part or you make the cut in the assembly. Which is pretty obvious once your customer part disappears. So let's maybe cut that away. And this is where I just kind of do the Etch-a-Sketch Instant 3D, see how far it goes. And then if I'm doing a customer design review, right, I ask the customer. The customer doesn't know that it's not fully defined, and they don't really care, as long as I give them good parts at the end. So that's kind of close-ish, right? Potentially we want to go out a lot more and then shore that up. I don't know, is that okay, Jerry? Or do we need to capture that?
We captured it.
Okay. So we just bring that back. You captured it kind of like that?
Actually, all the way to the end, but then just put a second piece to check the, yeah, that's basically what we did right there.
So like that's okay.
Yeah.
And then we still need to put a piece on here to butt that up against?
Well, actually, no, that was where the...
That's the slider, because you can't get it out otherwise.
Right.
Oh, okay. So this one here looks pretty good, right? To get rid of that, I would have to start a sketch on the top here and basically just draw relief. This is going to be crude, but you guys will get the idea. And figure out how far I have to cut out to get around that. Because I'm assuming it's okay if we just come down from that mill op and clear that out, or do we have to angle it and clear it out in line?
We angled it, but you can come down straight.
You could probably,
Clearance.
even if you design an angle, you could probably come back down with a lollipop cutter and eke it out. Okay. So standard operation there, right? No problem. I don't like the way this pulls. That looks really ugly, and it's not. I'm not a fan. I don't know if I can fix that easily. So let's go back past this, past the knits. Get rid of the body. Look at the boundary surface. No. So the only way to do that would be in pieces. So let's go past the boundary surface. This is just a cosmetic thing, and then I don't like all the lines in the pull in the material, because the pull will show up in the CNC as well. So if you don't do the chain and you do a single boundary surface here, you can actually pull these handles around. So right, that looks a little bit better to me. And then let's do another boundary surface from here to here. That looks fine. And now I can do a fill surface. Nope. Fill surface from there. Actually, first I have to knit this all together. After it's knitted, I can do a fill surface, right click, select open loop, and then it will fill that in and make that all, put a stupid root. Why is the fill doing that? I don't know. So we'll go back to boundary surface, grab that and grab that. On our direction 2, do that and do not green check. On our direction 2, do a selection manager, grab these 2 points, and then it'll still put a line in there because it has to blend that, but that looks a lot nicer to me. So now we can go back to screwing up everything else. Okay, what happened? Okay, where did all that come from? Ah, so I don't need that boundary surface. That's what happened. Get rid of that. Okay, rule surface. Update some edge selections, no problem. Do that edge, other direction, that, then that. And then this is the boundary surface with the 3D sketch. Because I knitted it, all the surface IDs got lost. That's kind of one of the dangers of redoing surfacing stuff, is you can lose a lot more face IDs and stuff than in the traditional modeling context. But here to there, and then selection manager. Selection manager allows you to pick more than one entity in a selection. If anybody's not familiar with selection manager or didn't know what I was doing, that's what that is. So let's re-knit all of this together. And the quick selection for knit is just a box, by the way. So the nice thing about using the cut with surface is as long as your surface body knit ID, as in the singular surface in the structure based on how those IDs are built, and your body stays the same, your cut with surface is extraordinarily reliable. So even though I hacked and slashed and totally decimated all the surfaces and the surface IDs and the edge constraints and all that kind of stuff, once you get back down to the surface cut, super reliable. that's the reason why I always encourage a surface cut or the knit or the thicken to make solid versus doing it baked into another feature. Because if your other feature gets destroyed or dies, then your body solid surface transition gets destroyed, and then all of your feature tree gets destroyed down below it. All right, so the body delate now, we still want that. Okay, we're looking good. I don't know if it was worth the 5 minutes to clean that up, but I did not like how it looked. Okay, so let's say I want to start filleting things that are not tangent. Who knows how to figure out what's tangent and not? Ideas?
Try to fillet it.
Try to fillet it, right? That's a super great idea. And you just start clicking on a whole bunch of stuff, right? And like, oh, that didn't work, right? Different idea. Who knows? Pro tip, go to View. Now I gotta find it. Display, maybe? Tangent edges removed. No. View helps if you click slower. Tangent edges removed. You gotta do a Control Q because graphics are graphics. And notice the tangent lines in here moved. Who right clicks on your drawing views and says tangent edges removed or shown or whatever? In your 2D drawings, right? Who does that? The exact same thing is possible in your 3D view. You just have to go through the View command, or the View drop down, Display, and then tangent edges removed. So same thing in the 2D drawing. So now I can stare at this, and I mean, obviously this is a hard edge because it's a hard edge. But I now know I can fillet all of the visible edges where I may not know where there's continuity in the tangency. So let's do an 1/8 inch, that's fine. Let's start grabbing these edges. Make this all look nice. Notice these are very, very small, and that actually had an inflection in it. Green check. And now all those lines have disappeared because they're all now tangent. Now I don't really like, I just did that for exercise, right? That should be much, much larger. So I'm gonna do a 1/2 inch, which is gonna fail. So I'd probably like, before we do that, let's do this for real, right? So I might do 1 inch here, 2 inches here, something large to manage that transition. And then everything else can probably just be that 1/8 inch that we had before. And then I'm guessing these lines we don't want hard because you don't want to scratch something, scratch the tubing or something. So I'm going to do another fillet, and we'll just put something really small on here, like 5 thousandths or 15 thousandths.
Like a 1/2 mil to 20 thou.
Yeah, you can't do commie speak. I don't know what that is. What do you want? 20 thou?
Yeah.
Okay. Yeah, so obviously we've got some cleanup, right? And I'm just trying to optimize the time in the presentation for it as. I will state that my end goal is to make 2D prints. So as long as I find favor in the user group leader's eyes, I'll be doing this every meeting on the same data and getting to physical 2D prints that if somebody needed to, they could actually manufacture this item. I might even get into like the work orders and the purchase orders and actually like try to schedule and route shop manufacturing and purchasing as an end goal. However long this takes, I don't know. So go back to View, Display, Tangent Edges Visible, Rebuild, Rebuild, Save. Just make sure nothing blows up. You can kind of see the inflection, the fillet, and everything that's going on. Back to my model. Now this again would be bolted and doweled to the bottom, no problem, same old, same old. One thing that's good to check if you're unsure about undercuts is to pick on a neutral surface and under Evaluate, under... I'll find it. Undercut analysis. It's aptly named. And you can kind of see gray is just going to be a straight 90, and then you can do gradients to kind of show errors and stuff. But all this looks pretty good. So it's not like, I was a little worried about this face here, one reason to put a big fillet on it, but it looks like it's all pretty good. So in a complex stuff like this, it's always good to run the analysis to make sure that you know that it can actually be cut. So that's that. We'll have to cut that off a little bit, right? So let's edit the part, start a sketch on the top plane, normal to. We kind of want it to cut through there, give or take. That's probably a little aggressive. We can just cut that out, right? No real reason to cut out more than that. Through all, other direction, and you'd have to fill at the inside corner and all that. I actually don't need any of that on the right side, do I? I can just do a... I don't remember how this was made now. So let's see. That we can shimmy over 37 1/4. Yeah, sure. It's kind of fun to watch all the surfacing now update and jump as the part moves. It still amazes me how quickly SolidWorks can process all of that. It's really an amazing technological software feat. And I'm just cleaning it up here, right? Try to make it. I'm trying to get to the point in which I could do a design review with an end customer, like, hey, you know, this is how we thought about holding the part. Does this make sense? Is it going to meet your requirements? We all understand it doesn't have to be pretty. It doesn't have to work. Stuff isn't defined. I get all that. I'm just trying to replicate my real workflow. If I was actually designing this for Jerry for a project, to get as close as I can to a presentation point, and then go through, clean everything up, make all the manufacturing prints, and put it out to production. So let's look at the photo. You're holding tubes here. We got the one end, not the other. We got that end. I don't know what's in the black spot, something that's secretive. I understand. That's your redaction. Okay, so I'll quick do these tubes here a minute just for funsies. Because I think I got like 10 minutes until somebody walks through that door and tells me I'm done. So same thing kind of here, right? Would you do a riser block and just machine that little piece? Or would you just machine it on the end of that riser block?
Make one big block.
Okay, just have a big right angle plate in the mill to hold it. Okay, perfect. So I'm just going to copy or open this, do a save as, copy, nest 6, and back to here, insert nest 6, find this, the top plane, mate that, normal to the top plane, put the part there, rotate it to kind of match the tubing, which the tubing is not parallel, so that's helpful. Say 2.5 is fine, it can be square, I'm okay. It's too tall, and I thought I mated that to the top plane. Wrong top plane. Let's try that again. It's not that top plane, it's the base plane. All right, so it is not too tall. 11. I'm assuming we need more capture than that.
Like half the tube.
Oh, half, okay, so we're just over half. So same thing, we're gonna edit the part under surfaces, offset, grab these, 10 thou, good, open the part, and hide the part, top plane, split line, grab those two, good, no, one by a time, come on SolidWorks, get with it. Top plane, split, good. Gonna delete the top halves of those tubes. Yeah. Okay. Let's just boundary between the two, because why not? Pick that, pick that. That doesn't seem like it's gonna work well. That's too sharp of an edge, right? Okay, so let's do something different. Let's do a ruled surface, pick these, or not that edge at all. Normal to surface, pick that and that, not normal to surface. Tangent to surface, and do one. I may have to remove knit. Okay, now on the front plane, I am just going to find the high edge on the front plane, insert a sketch, find the high edge, convert it, use that as a trim tool to use that, remove those. All right, happy with that. Now I can boundary surface those two together, right? That's good. And then let's rule these normal to the other direction, normal to surface out enough. Let's knit all this together. Again, you can go like that. I don't know why I keep forgetting. Let's show the body again. Use our cuts there, cuts. Delete our surface body. Go back to the assembly. Oh yeah, and I totally forgot to make my part in place. So as this moves around and I hit rebuild, the surfaces are gonna dynamically update. So that's exciting. All right, a good way to make this in place, I was told 10 after, I got 5 minutes, is let's, in this instance, I can probably just do an axis on one of these tubes and save that. And now I just have to show my axes. Let's grab this front plane and that axis and make it a distance of 1. Too much. 5. 0.375. Sure. And then now the only thing I've got is this angle. And that was going to be easily done by grabbing the origin and the right plane of my assembly, 8 1/8 inch. Save. And now this is fully defined, right? Not moving it at all. And this should be dowel tapped holes on the bottom, single contour up top. And I think the picture shows a distacle clamp or something, so I'd need to do that. But certainly, not to criticize the lovely picture and CAD data that you gave us, but certainly compared to machining that on an angle and doing the two-piece part, I think this would probably be a little bit more manufacturing effective. So that is what I have. Any questions in the last 3 minutes? All right, once these are uploaded, I promise to give all the CAD that I've created to date. So any of you can download it, watch the videos, do whatever you want. Tell me what I did wrong, explain all the errors, fix it up, come back next user group, give it back to me. That'd be great. Thank you very much.